In 1952, agricultural researchers from the University of California visited 6 farming villages outside Kyoto. They were measuring caloric output per acre. What they recorded didn't align with what American agricultural models predicted was possible. Each household they studied kept an average of 3 animals. Not 30, 3. A breeding pair of rabbits and 1 chicken. Sometimes 2 chickens. The plots measured between zero point 0.3 and zero point 0.6 acres. Yet these families reported stable protein intake year round, even through winters when nothing grew. The researchers published their data in the Journal of Agricultural Science in 1954. They noted the protein yield per square meter. They documented feed conversion rates. They recorded slaughter schedules and preservation methods. But they couldn't explain one measurement that kept appearing across all 6 sites. The families were harvesting more edible protein per animal than American farms were producing per 100-pound hog. It wasn't selective breeding. The rabbits were common Japanese whites. The chickens were local mixed breeds, nothing specialized. Feed was kitchen scraps, wild forage, and a small supplement of barley or rice bran. No imported grain, no soy, no industrial pellets. Yet, a single rabbit doe in these systems produced the caloric equivalent of 2 adult chickens annually, and the household never ran out. The cycle repeated without restocking. No hatchery orders, no replacement stock. The system reproduced itself. The report described the methods in technical language. It listed inputs, it measured outputs, but it didn't explain how a household could sustain this level of efficiency on so little land with so few animals, while American homesteads required 10 times the space and 50 times the feed cost to achieve similar results. The data was published, it was filed. And within 2 decades, as Japan industrialized and American style poultry operations expanded across Asia, the systems those families used were categorized as obsolete. But the measurements remain on record. If 3 animals and half an acre could sustain a family's protein needs indefinitely, without external inputs, without genetic engineering, without purchased feed, what did those households understand about biological efficiency that modern farming systematically erased? Stay with me. What you're about to hear could change how you understand survival. When food systems fracture, the first thing that disappears isn't grain, it's protein. During the 2008 global food crisis, rice prices tripled in 6 months, wheat doubled, but meat became functionally unavailable in parts of sub-Saharan Africa and Southeast Asia. Not because animals died, because the cost of feeding them exceeded what households could afford. Industrial livestock require constant external inputs. When those inputs spike or vanish, the animals become liabilities. A family raising 50 chickens needs 50 pounds of feed per week. If feed costs double, the household either sells the flock at a loss or watches them starve. Either way, the protein source collapses within 30 days. Now consider the inverse scenario. A household with 3 rabbits and 1 chicken, operating on the system those Kyoto farmers used, requires no purchased feed. The animals convert waste, vegetable scraps, lawn clippings, weeds, into meat. If external supply chains fail entirely, the system continues. If inflation makes feed unaffordable, it doesn't matter, the loop closes at the household level. This isn't theoretical. During the siege of Leningrad, from 1941 to 1944, over 1 million people died of starvation. The city was cut off. No supply lines, no imports. Residents who kept small rabbit colonies in apartment courtyards or basements survived at significantly higher rates than those dependent on rations. Soviet medical records from the siege document this. Rabbits were one of the few protein sources that didn't require industrial infrastructure. The difference wasn't luck, it was system design. Most modern preparation assumes short-term disruption. People stockpile freeze-dried meals. They buy 50-pound bags of rice. They freeze meat. All of this assumes the disruption will be temporary and the grid will return. But if the disruption extends beyond 90 days, those strategies decay. Freezers fail, rice depletes, and there's no way to produce more. The Kyoto model operated on a different assumption. It assumed continuity under scarcity. It assumed the household would need to produce protein indefinitely, with no resupply, using only what existed within the property line. A single breeding rabbit zoo produces 6 litters per year. Each litter averages 6 kits. That's 36 offspring annually. If half are kept for meat and half are culled or traded, the household harvests 18 rabbits. Each rabbit, dressed weight, yields roughly 3 pounds of meat. That's 54 pounds of protein per year from one animal. Add one chicken producing eggs, and you've matched the annual protein intake of an adult human on half an acre, with no purchased inputs. The system doesn't optimize for profit, it optimizes for endurance. And endurance is what fails first when people prepare for comfort instead of continuity. Rabbits weren't domesticated in Japan until the late 19th century, but the principles that made the Kyoto system work were already embedded in Japanese agricultural philosophy for over 1,000 years. The term Satoyama describes a managed border zone between village and wilderness. It's not wild, but it's not farmland. It's a working ecosystem. Households harvested firewood, wild vegetables, mushrooms, and medicinal plants from these zones. They grazed small animals there. They cycled nutrients back into their gardens. Nothing was wasted. Nothing was imported unless absolutely necessary. Rabbits fit this logic perfectly. In medieval Europe, monasteries raised rabbits in walled gardens called garens. The animals required no grain, no pasture, and no labor-intensive care. They converted weeds and scraps into meat. Monks documented the system in agricultural manuals as early as the 12th century. The measurements they recorded, feed conversion, litter size, time to slaughter weight, align almost exactly with what those University of California researchers measured in Kyoto 800 years later. The system wasn't cultural. It was biological. Rabbits are hindgut fermenters. Their digestive system is built to extract nutrition from fibrous plant material that other livestock can't process. A chicken can't digest cellulose efficiently. A pig needs starch and protein. A cow needs pasture. But a rabbit can sustain itself on weeds, grass clippings, and vegetable scraps that humans would otherwise compost or discard. That's why they worked in monastery gardens. That's why they worked in Kyoto. And that's why they worked in Leningrad when every other protein source collapsed. The households studied in 1952 didn't treat rabbits as livestock. They treated them as biological processes. The animals turned waste into calories. The system didn't require management. It required observation. Breeding cycles were timed to seasonal forage availability. Litters were born when wild greens were abundant. Kits were weaned onto dandelion, clover, and plantain, plants that grow everywhere and require no cultivation. Slaughter schedules matched household need, not market price. There were no feedlots, no climate-controlled barns, no veterinary interventions. The animals lived in simple hutches made from reclaimed wood and wire. When a doe stopped producing, she was culled. When a kit showed poor growth, it was removed from the breeding line. The system selected for efficiency, not sentiment. This wasn't cruelty, it was clarity. The families running these systems understood something modern livestock science has deliberately obscured. The best survival animal isn't the one that produces the most. It's the one that produces reliably with the least input. Rabbits met that standard. And for over 1,000 years, from European monasteries to Japanese villages, humans engineered household food systems around that logic. Then industrial agriculture introduced a competing model, and the logic reversed. In the winter of 1945, as Berlin collapsed under Allied bombardment, city residents faced total food system failure. Grocery stores were empty. Ration cards became worthless. Supply convoys couldn't enter the city. Industrial livestock operations had been destroyed or evacuated. Yet, some families continued eating protein. Post war Allied surveys documented what kept them alive. Among the most frequently cited resources were Stallhasen, urban rabbit colonies kept in basements, attics, and bombed out courtyards. Families who maintained even 2 or 3 breeding rabbits had a protein source that continued functioning when every other system had failed. The German Federal Archives contain dozens of civilian diaries from this period. Many describe slaughtering a rabbit as the difference between survival and starvation during multi-week stretches when no other food entered the household. One entry, dated February 1945, describes a single rabbit feeding a family of 5 for 3 days. Another records a woman trading rabbit pelts for potatoes because the skins held value even when currency didn't. These weren't farmers. They were teachers, clerks, factory workers, people who had never raised animals before the war. But they learned because the biological simplicity of rabbits made learning possible under catastrophic conditions. A rabbit reaches slaughter weight in 8 to 12 weeks. A chicken takes 16 to 20. A pig takes 6 months. A cow takes 2 years. In a crisis, time becomes the limiting factor. Rabbits reproduce and mature faster than any other commonly domesticated meat animal. That speed is what allowed households to establish protein security within a single season, even after starting from zero. This pattern repeated across multiple conflicts. During the 1992 to 1995 siege of Sarajevo, residents trapped inside the city faced near total food blockade. Humanitarian aid was inconsistent, markets collapsed, yet urban rabbit farming became one of the most reliable survival strategies. Bosnian agricultural reports from the post-war period describe how families kept rabbits on apartment balconies, feeding them weeds collected from vacant lots. Some of these operations started with a single pregnant doe acquired through barter. Within 6 months, those families had a renewable protein source. The data is clear. When centralized food systems collapse, whether through war, blockade, or economic failure, decentralized household animal systems outperform every modern alternative. Not because they produce more, because they produce continuously, using resources no one else is competing for. The Kyoto farmers weren't doing anything exceptional. They were practicing a form of biological efficiency that has been tested under the worst conditions humans have ever faced. And every time, it worked. The question isn't whether small scale rabbit systems can sustain a household. History has already answered that. The question is, why did we stop teaching people how to build them? The erasure of household rabbit systems wasn't accidental. It was economically necessary. In the 1950s and 60s, as industrial agriculture scaled in the United States and Europe, food production shifted from a household function to a purchase service. Governments and agribusiness corporations promoted this shift through policy, subsidies, and infrastructure investment. The goal was efficiency at the national level, not resilience at the household level. Household systems don't generate recurring revenue. A family that produces its own protein indefinitely never enters the supply chain as a customer. They don't buy feed. They don't buy replacement stock. They don't require veterinary pharmaceuticals, vaccines, or growth hormones. From a market perspective, they're economically invisible. Industrial livestock, by contrast, generates profit at every stage. Feed production, breeding stock sales, transportation, slaughter, packaging, distribution, retail, every step is monetized. The system is built to require continuous input and continuous consumption. Household rabbit systems operate outside this loop. They're too simple, too decentralized, too self-sufficient. You cannot build a supply chain around an animal that eats weeds. Agricultural extension programs in the US and Europe stopped teaching rabbit husbandry by the 1970s. Textbooks removed it from curriculums. 4-H clubs shifted focus to cattle and poultry, animals that connected young people to commercial farming. Rabbits were reclassified as pets, not livestock. This wasn't a conspiracy. It was economic specialization. As food systems centralized, the skills required to operate outside those systems became functionally obsolete. Households became consumers, not producers. And within 2 generations, the knowledge that sustained families through famines and sieges was reduced to a footnote in agricultural history. The logic is consistent. Systems optimize for profit, not survival. Profit requires dependence. Survival requires autonomy. The two models are incompatible. This same pattern appears in seed saving, water collection, and home food preservation. Any practice that allows households to meet their own needs indefinitely is economically non viable at scale. So it gets replaced by a model that requires you to keep buying. The Kyoto farmers weren't resisting modernity. They were practicing a form of resource management that industrial economies cannot monetize. And when something can't be sold, it stops being taught. That's not malice. That's just how markets work. But it leaves households dependent on systems that fail under pressure. And when they fail, most people no longer know what their grandparents did. In 2019, researchers at the University of Michigan published a study in the journal Sustainability Analyzing Protein Production Efficiency in Small Scale Household Systems. They compared rabbits, chickens, goats, and pigs across 3 metrics: land use, feed conversion ratio, and time to harvest. Rabbits outperformed every other animal in all 3 categories. Feed conversion ratio measures how many pounds of feed are required to produce 1 pound of meat. Industrial broiler chickens, bred for maximum growth, achieve roughly 2 to 1. Pigs average 3 to 1. Cattle range from 6 to 1 to 10 to 1. Rabbits, fed on forage greens and vegetable scraps, achieve approximately 3 to 1, but without requiring purchased feed. The inputs are waste streams the household already produces. The study calculated that a family of 4 could meet its annual protein requirements with 0.4 acres and 6 breeding rabbits. No grain purchases, no off-site inputs. The system was entirely closed loop within the property boundary. This matched the Kyoto data exactly. Nutritionally, rabbit meat is one of the most efficient proteins available. It contains more protein per ounce than chicken, beef, or pork. It's leaner than any commonly consumed livestock. A 2017 analysis by the Food and Agriculture Organization listed rabbit as one of the highest yield, lowest input proteins for household food security in resource scarce environments. Yet, despite this data, rabbit consumption in the United States remains below 0.1% of total meat intake. The infrastructure doesn't exist. Most processors won't accept them. Grocery stores don't stock them. And because there's no market, there's no incentive to teach people how to raise them. But the biology hasn't changed. In 2021, a team of researchers in Spain tested rabbit systems as a climate resilient protein source. They measured methane emissions, water use, and land degradation compared to cattle and poultry. Rabbits produced 90% less methane than cattle. They required 85% less water than pigs. And because they don't require tilled fields or monoculture feed crops, they caused virtually no soil degradation. The study concluded that rabbit based household protein systems represent one of the most sustainable, scalable models for decentralized food security under climate instability. They weren't discovering anything new. They were confirming what medieval monks, Japanese subsistence farmers, and Bosnian siege survivors already knew. The system works. It has always worked. And every time researchers measure it, the data supports the same conclusion. If your goal is to feed a household indefinitely, on minimal land, with no external inputs, rabbits are the most efficient animal you can raise. The science didn't create the system, it validated it. And the validation has been published in peer-reviewed journals for over 70 years. We just stopped reading it. In 1952, those researchers standing in Kyoto were measuring something that no longer fit the direction their own country was moving. America was industrializing food. Japan would follow within a decade. The households they documented were already being described as remnants of a pre modern era, but the measurements didn't lie. 3 animals, half an acre, year round protein security, no dependence on external supply chains, no vulnerability to price shocks or transportation failures. The system wasn't inferior, it was structurally different. It optimized for a future those researchers didn't think was coming. That future is here now. Global food systems are more fragile than they've ever been. Supply chains span continents. A single point of failure, a port closure, a fuel shortage, a currency collapse can cascade into regional food insecurity within weeks. We've built efficiency, but we've sacrificed redundancy. And in complex systems, redundancy is what survives. The households in Kyoto weren't trying to compete with industrial farms. They were ensuring that if everything else failed, they could still eat. That logic isn't romantic, it's structural. Climate instability will continue to disrupt industrial agriculture. Water scarcity will make feed crops more expensive. Fossil fuel costs will make transportation unpredictable. And as centralized systems become more brittle, the households that retain the ability to produce their own food will have an advantage that no amount of stockpiling can replicate. Because stockpiles run out. Systems that reproduce themselves don't. The knowledge those families practiced wasn't primitive. It was tested, refined, passed down, and then erased. Not because it failed, but because it didn't scale. But survival has never been about scale. It's about continuity. In 1952, a contradiction was recorded. A household system that shouldn't have worked, according to modern assumptions, did work. It worked efficiently. It worked reliably. And it worked without requiring anything the household couldn't provide. That contradiction was never resolved. It was just filed away. But the data remains. And so does the system. If remembering what was forgotten matters to you, subscribe to Roots of Survival. Every share helps keep this knowledge alive.